Suppose f and g are differentiable functions over an open interval containing a, except possibility at a. If the limit at x approaches a of f of x and divide by the limit as x approaches a of g of x is of the indeterminate form, then the limit of the quotient f of x divided by g of x as x approaches a is the same as the limit as x approaches a of f prime of x divided by g prime of x. Assuming the limit on the rise is exit or is plus or minus infinity, this result also holds if we consider in one-sided limit or if a is at plus and minus infinity. Now the indeterminate form are of the form 0 divided by 0, infinity by infinity, infinity minus infinity, 0 to 0, 1 to infinity. So let's go ahead and prove the indeterminate form where we have 0 divided by 0. So we want to prove, so let's prove case 1. Zero divided by 0. So this meant here we're saying that the limit at x approaches a of f of x is equal to 0 equal to the limit at x approaches a of g of x. Okay. And since the function is continuous at x equal a and differentiable, I can then write this as is equal the limit at x approaches a times f of x minus f of a divided by g of x minus g of a. Note that here f of a and g of a is equal to 0, right? Because the function is continuous at that point. So then I can rewrite this as the limit at x approaches a of f of x minus f of a divided by x minus a. I divide the numerator and denominator by x minus a. Okay. So this is the same as saying the limit at the numerator divide the limit of the denominator okay. So by definition of derivative, this is equivalent with saying the limit with saying that we have f prime of a divided by g prime of a. Okay. This means I can say that the limit at x approaches a of f prime of a then divide by the limit at x approaches a of g prime of a, of x. So that's what that meant. Okay. Then equal to the limit at x approaches a of f prime of x divided by g prime of x by definition. And so we have proved the L'Hospital theorem rule for the case 1 of the indeterminate. Now take a look at a couple examples. Determine the indeterminate form of determine the indeterminate form and apply the L'Hospital rule if possible to find the limit of the following. So what is this case? This is of the 0 by 0 So then I can take the derivative of the numerator. So then this becomes the limit that x approaches 0. What is the derivative of the numerator? That is 1 divided by 2 root of 1 plus x. Is that right? That 1 divided by 2 root of 1 plus x minus 1, that is 0. Derivative of x equal 1. So at x approaches 0 here, then this equal to 1 over 2. In our next case, let's see what happened when x approaches to 0. When x goes to 0, cosine of 0 equal 1. This is 0. Go to 0. Again, we have the case of 0 over 0. So go ahead and we will find the derivative of the numerator. Derivative of cosine of x equal negative sign, with the negative make positive side of x. Divide by 1 plus 2x. So this equals sine of 0. Sine of 0 equal to 0. What is secant of pi over 2? So recall secant of x equal 1 over cosine of x. So that equal 1 divided by cosine of x, then that equal to cosine of pi over 2, that is close to 0, right? It's going to 0. It is a very small number. This means that we have the numerator is of infinity. Yeah. 1 plus tangent of x, tangent of pi over 2, that go to positive infinity. So this is infinity by infinity is our indeterminate form. So then the limit at x approaches pi over 2. Derivative of secant is secant of x, tangent of x. Divide by 1 plus secant squared of x. Let's go ahead and simplify secant of x and tangent of x plus 1 divided by 1 plus secant of x. Now secant of x times tangent of x is equal 1 over cosine of x times sine of x divided by cosine of x, that equals sine of x over cosine squared of x. 1 plus secant squared of x equal 1 plus 1 over cosine squared of x, that is cosine squared of x plus 1 divided by cosine squared of x. So then this simplifies to the limit at x approaches pi over 2 of sine of x divided by cosine squared of x plus 1. Limit of sine of pi over 2, that is 1. Cosine of pi over 2, that is 0 square, that makes 0 divided by 1. This equal to 1. The next case, we have the limit at x approaches 0 of square root of x times ln of x. Okay, so note that at x approaches 0 from the right, the square root of x is 0. ln of x at x approaches 0, that is to infinity. So we are of the determinant form of so here we don't know what we don't quite sure what determinant form that we have. So we need to manipulate this a little bit. So the limit at x approaches 0 from the right, I can rewrite in this at ln of x divide by 1 over square root of x. Now then the limit as ln of x approaches to of ln of x at x approaches 0 on the right, that is then it go to infinity, right? Now what happens when we have 1 over square root of x as x approaches 0? That's also infinity. So this is of the infinity by infinity for the indeterminate form. So then the limit at x approaches 0, derivative of ln of x, that is 1 over x, derivative of 1 over square root x, that is negative 1 over 2 times square root of x. Excuse me, this would be times x to the negative 3/2. So let's simplify this. Of 1 over x times negative 1/2. So this is what so 1 over x is x to the negative 1. So bring that to the denominator. So you get 1 over negative 1/2 x to the 3 over 2 times x to the first. That is the limit. X approaches 0 from the right. 1 divided by negative 1/2 x to the negative 1/2. So this is x to the 1/2 divided by negative 1/2. Okay, and the limit at x approaches 0 to the right. So then this equal to 0. Okay. So here at x approaches 0, we have the indeterminate form of negative infinity, of infinity minus infinity. So we have to do some manipulation because our L'Hospital form only have to do with the quotient. So we need to do some algebra. So consider 1 over sine x minus 1 over x, that equal x minus sine of x divided by x times sine of x. Okay. So we rewrite this as the limit at x approaches 0 of x minus sine of x divided by x times sine of x. So we now back to the indeterminate form of 0 by 0. We can apply the L'Hospital rule here to get the limit at x approaches 0 of 1 minus cosine of x divided by sine of x plus sine of x minus, plus x times cosine of x. Note that we still at the indeterminate form of 0 by 0 here. So we go ahead and apply the L'Hospital rule one more time. The limit at x approaches 0 of 1 plus sine of x, of sine of x divided by cosine of x plus cosine of x minus x times sine of x. This equals the limit at x approaches 0 of sine of x divided by 2 cosine of x minus sine of x. So then this equal to 0. In the next problem, note that here we have an exponent of a function, right? So we start by let y equal the function in question, x plus 2 divided by x minus 1 to the x. Then if I go ahead and take ln of y, then I get x times ln of x plus 2 divided by x minus 1. This means the limit at x approaches infinity of ln of y is equal the limit at x approaches infinity of x times ln of x plus 2 over x minus 1. Let's take a look at the right hand side. The limit at x approaches infinity of x times ln of x plus 2 divided by x minus 1. I can rewrite this as the limit at x approaches infinity of ln of x plus 2 divided by x minus 1 divided by 1 over x. Now I have this in terms of 0 by 0. Excuse me, I have this in term, yeah, that's right, 0 by 0, right? So then here, what we have, I can then go ahead and take the derivative of numerator divided by the denominator. So then this equal to the limit at x approaches infinity of 1 of x minus 1 divided by x plus 2 multiply x minus 1 minus x plus 2 divided by x minus 1 squared together divided by negative 1 over x squared. This simplifies to the limit at x approaches infinity of 3 over x plus 2 times x minus 1. As x approaches infinity, 3x squared here. As x approaches infinity, this becomes 3. Let's put together the left hand side and the right hand side. We have the limit at x approaches infinity of ln of y equal 3. This is the same as saying ln of the limit at x approaches at x approaches infinity of y equal 3. So then the limit at x approaches infinity of y is equal e to the third. In the next case, I need to work on the function itself first. So let's rewrite the function x squared divided by x times e to the x. Note that this is e times x, e to the x times x divided by x times e to the x. This is the same as e to the x times e to the negative x divided by x. I go ahead and rewrite this as e. I'll go ahead and rewrite this as e to the x times x minus 1 divided by x. And I take a look at the limit at x approaches 0 of e to the x minus 1 divided by x. I'll apply the L'Hospital rule here to get the limit at x approaches 0 of e to the x times x minus 1 times 2x minus 1 divided by 1. So this limit if we apply 0 here in this case, 2 times 0, that go to 0, just go to 0. So this whole limit looking at e to the 0 equal 1.